Hello all, my name is Krishnak and welcome to my YouTube channel. Now this was one of the most requested video by you all guys. So in this video we'll be discussing about all the metrics in a classification problem statement. Guys, this is just the part 1 and I've listed down all the important metrics that you can actually use for understanding whether your machine learning algorithm is predicting well or not. Okay, so some of the metrics over here are confusion matrix. Okay, then we'll understand about accuracy. Then we'll understand about type 1 error, type 2 error. Then we have concepts like recall, which is also called as true positive red. Then we'll discuss about precision, which is also called as positive prediction value. Okay. Then we'll understand about F beta. And in the next part, in the next video, we'll basically be understanding about Cohen-Kappa, ROC curve, AUC score, and something called as PR curve. There are two more metrics again which I'll discuss in the part 2 because I did not have space to write it down. So we'll be discussing about that in our next part 2. In the part 3, I'll try to implement a problem statement considering an imbalanced data set, and I'll try to apply all these particular metrics, and I'll show you that how the accuracy will look like. So make sure guys you watch this particular video completely and make sure that you understand things. Okay, the reason why I'm saying, even though you are a very good data scientist and you know how to actually use a machine learning algorithm with respect to your data, but if you are not using the correct kind of metrics to find out how good your model is, then it is completely a waste of time. You know, because if you have not selected the right metrics and then you have deployed your model to the production, right, you'll be able to see that because of the metrics, because of the wrong metrics that you have chosen, that will actually give you a very bad accuracy again when the model is actually deployed in the production. So let us go ahead and try to understand the metrics, and in this particular video I'll be making like a story. Okay, so part 1 will just be like a story, and then I'll continue and I'll explain you each and every metrics over here. Now understand one thing guys, suppose we have a problem statement. So this is a problem statement, specifically a classification problem statement. Okay, classification problem statement. Now in classification problem statement, right, there are two ways how you can solve the classification problem. One way is basically through class labels. Suppose you want to predict class labels. Okay, the next way is through probabilities. Now suppose let me just consider a binary classification. In a binary classification, I know there will be two different classes, A or B. Suppose this is my A or B. So my output will either be A or B. Okay. By default, the threshold value will be taken as 0.5. What does this basically mean? Suppose I am predicting with some of my machine learning model like logistic regression. By default, if I predict, if it is greater than 0.5, then it will become a B class. If it is less than 0.5, then it becomes a A class. I mean less than or equal to 0.5, then it will become a A class. But in case of probabilities, here we have to also find out the class labels. How? We have to basically select the right threshold value, which is this P value. Okay, I'll not say P value, but I'll instead say some threshold value. In some of the healthcare sector, this threshold value may decrease. You will be saying that suppose if a person is having cancer or not, at that time this threshold value should be chosen in a proper way. If it is not chosen in a proper way, the person who is having cancer will be missed out, right? So in probabilities we will be discussing, and in probabilities what all we have basically ROC curve, AUC curve, AUC score and PR curve, which we'll be discussing in the part 2. In the part 1 we'll be focusing more on this class labels where our default probability is 0.5. Okay, so I hope you are getting it, right? So understand that thing. If we have a classification problem, usually what we do is that they have two types of problem statements over here. With respect to the class labels, we need to find out what is the output of that particular record, or based on probabilities where we have to first of all find out a threshold value. Okay, in logistic regression, I may find out that the threshold value may be 0.3, maybe 0.4. That basically means that if my output is less than or equal to 0.4, it becomes class A. If my output is greater than 0.4, then it becomes class B, right? And this I'll be showing you how you can actually find out with the help of ROC curve and PR curve. Okay, so that will come in the part 2. Now let us go ahead one more thing now over here. Now with respect to this problem statement, we have two problem statements based on the output. Okay, based on the output. Suppose in this particular problem statement I have 1000 records. Okay, I have 1000 records. Okay, now with respect to 1000 records, suppose this is a binary classification problem. That basically means suppose I have 500 yes, that basically means 500 records which has yes as an output, and I have 500 no as my other output, or I may have 600 yes or 400 no, right? Now in this case, what I can suggest is that this looks like a balanced data set. Okay, balanced data set basically means that yes, you have almost same number of yes and same number of no. So both the output labels are almost same. Similarly, if you could take 700 yes and 300 no, this is also fine. This looks like a balanced data set. Okay, now understand one thing, guys. Why I'm saying balanced data set? Over here, the number of yes and no are almost equal. In this case, you may be suggesting, Chris, there is a difference of 400, but it is fine. Why? I'll tell you. If we have this kind of data set also, and if we try to provide this kind of data points to our machine learning algorithm, my machine learning algorithm will not get biased based on the maximum number of output. Okay, but if we have scenarios where in our data set ranges, and this is basically 70 to 30, right? 70 to 30%. Basically 70 to 30 ratio. Here you have basically like a 60-40 ratio. Here you have 50-50 ratio, right? But now if I go one more level down, like 80-20 ratio. 80-20 ratio basically means that suppose I have over here 800 record and here I have 200. Right? Now in this case, when I provide this kind of imbalanced data set to my machine learning algorithm, some of the machine learning algorithm will get biased based on the maximum number of output. Okay? Now, if we have a balanced data set, the type of metrics that is basically used is something called as accuracy. If we have an imbalanced data set, at that time we do not consider accuracy. Instead, we consider something called as recall, precision, and F beta. I'll explain you about what exactly is F beta score, which is also called as F1 score if you have heard of most of it. But this F1 score is derived by this beta value that we'll be discussing about. Now just consider, guys, initially let us take that suppose my data set is balanced. Okay, at that time I'll try to explain you accuracy, and then we will then understand if our data becomes imbalanced, how do we solve this particular problem. Okay, so let us go ahead. I'm just going to rub this thing, and if you have not understood, just just go back again, see this particular explanation what I've given. Okay, now first of all, if we have a binary classification problem, guys, we need to understand what exactly is a confusion matrix. Now understand one thing, guys, confusion matrix is nothing but it is a 2x2 matrix in case of binary classification problem, where the top values are actually the actual values. Okay, the top values are the actual values. Over here, actual values like 0 or 1, 1 or 0. Suppose I consider this as 1 and 0. And similarly, in the left hand side, these all are my predicted values. So this basically values indicate that what my model has actually predicted. So this will also become 1 and 0. So usually what we do is that each and every field we specify with some notations. So the first field in this case is something called as true positive. The second field is something called as true false positive, and the third field is something called as false negative, and the fourth field is something called as true negative. We'll try to understand more in depth what exactly these fields mean. Okay, what is false positive, what is false negative. And by default, if I consider this type 1, this is called as type 1 error. Okay, so if I want to consider this false positive, this is basically called as a type 1 error. We can also compute the type 1 error with the help of false positive rate. Okay, false positive rate. I'll define the formula in just a while. This Fn is basically called as a type 2 error. And this is also mentioned like false negative rate. Now, what does this false positive mean? Now, if you want to define false positive rate, how do we do is that we basically consider this false values with respect to your actual and predicted, and the false positive rate is basically given by Fp divided by Fp plus Tn. Okay, this true negative and this, and always remember, guys, these are your most accurate results. Okay, Tp and Tn, and always your aim should be, okay, in any classification problem, to reduce your type 1 error and to reduce your type 2 error. Okay, you always have to focus on reducing your type 1 error and reducing your type 2 error. Okay, now understand one thing, guys. since this is a balanced problem statement, right? So what we do is that we directly compute the accuracy. Now how do we compute the accuracy is that we simply add TP plus TN divided by TP plus FP plus FN plus TN. That basically means I'm just saying that this diagonal elements, which will actually be giving me the right result, divided by total number of bits, and this will give us the accuracy. Why I'm following this particular stuff? Because I'm considering this problem statement is my balanced data set. Okay, and during the balanced data set, usually my model does not get biased based on the different types of categories that we have in this binary classification problem. Okay, but now what if my data set is not balanced? What if my data set is not balanced? Let me give you a very good example. Suppose one category I have some 900 values. Suppose out of the 1000 records I have 901 category and 100 as my another category. Okay, 100 as my another category. Now if I apply, just understand over here guys, if I just say that my model will bluntly say that everything belongs to category A and not to category B. Okay, not to category B, but instead it will say that every values or every test data set belongs to my category A instead of category B. Okay, so out of this I'm just suggesting that, okay, 900 values, and I'm considering this is my test data, suppose guys. Okay, suppose I'm having this test data, or just consider that I had my trained data. In my trained data I had 1500 records, out of which 1200 was my class A category and 300 was my class B category. And now I have divided that into train test split. Inside my test data, suppose I had around I'm just considering an example. In my test data I had class A as 900 records and class B as 100 records. Now suppose if my model predicted all the classes were class A, now in that specific case, if I said TP plus TN, I'm just going to get a 90% accuracy, right? Because there true positive I'll be getting 900, true negative I'll be getting 0, and if I do the summation of all of this will become 1000, and this is in short 90% of accuracy, right? So this is a problem, right? If we have an imbalanced data set, we cannot just use accuracy, because it will give you a very, very bad meaning about that particular model. You know, you're just blindly saying that it belongs to just one category. So if you have an imbalanced data set, you basically go with something called as recall, precision, right, and something called as F beta score. Now let us go ahead and try to understand about recall and precision. Okay guys, now let us go ahead and understand what exactly is recall and precision. Now guys, here is my confusion matrix. Here you have true positive, false negative, and true negative. And understand why do we use this? For an imbalanced data set. Now understand one thing guys, any kind of data set that you have, you should always try to reduce your type 1 error and type 2 error. Okay, you should always try to reduce this. Now specifically when your data set is imbalanced, we should either focus on recall and precision. Now what does recall over here formula says? Recall basically says that TP, so these are my actual values, right? These are my predicted values. So this basically says that TP divided by TP plus FN. Okay, TP divided by TP plus FN. Now what does this say is that out of the total positive actual values, how many values did we correctly predicted positively? Okay, this is what this recall basically says. Again, I'm repeating it guys. Out of the total actual positive values, one is positive, right? I can say true or positive, anything. Out of all this, how many positive did we predict correctly? That is what this recall basically says. Recall is also given by something called as true positive rate. It is also mentioned by true positive rate, or it is also mentioned by sensitivity. Okay, it is also mentioned by sensitivity. Now similarly, if I consider about precision, it basically says TP divided by TP plus FP. Okay, now what does this basically say? Out of the total predicted positive result, how many results were actual positive? Okay, here we are actually focusing on a false positive. Here in the recall we are actually focusing on false negative, right? So again I'm repeating it. What does precision basically say? Out of the total actual positive predicted results, how many were actually positive? And what is the proportion that were actual positive? That is what this particular precision basically say. And for precision, we also specify another name which is called as positive prediction value. Suppose in your interview they ask you what is actually positive prediction value, you have to explain the same thing. Understand these things, guys. Now, when should we use recall and precision? Understand, guys. Let me just give you some very good example of recall and precision. So I have a use case which is called as spam detection. In spam detection, I have to focus on precision. Why? Consider that, suppose in this false positive, which basically says that, suppose this mail is not a spam. Okay, suppose it is mail is not a spam, but the model has predicted that it is a spam. That is your false positive. Okay, again I'm telling you guys, the mail is not a spam, but it has been predicted that it is a spam. So this is what it is saying. 0 basically means not a spam, but it has predicted that it is a spam. Now in this particular scenario, what will happen is that we should try to reduce this false positive value. We should try to reduce it false positive value, because understand, in this case, in a spam mail detection, if it is not a spam and if it is specified or predicted as a spam, the customer is going to miss that particular mail, which may be a very important mail itself, right? So because of that, we should always try to reduce this false positive value in the case of this kind of use case, that is spam detection. But what about recall? Suppose I say that whether the person is having cancer or not. Cancer or not. Okay, so my 1 value basically specifies that he is having cancer. 0 specifies that he is not having cancer. Now in this particular case, we should try to reduce false negative. Why? Understand guys this one. Now consider that if the person is having a cancer, actually he is having a cancer, but he is predicted as that the person is not having by the model. Okay, so that is what it says over here. These are my actual values. Suppose he is suffering from cancer. So that what exactly the actual value says, right? But the model has predicted that the person is not having a cancer. So this may be a disaster, because again understand, if I get an error in false positive, then the person will go with another further test to understand whether he is having cancer or not. But if my model predicted that even though he had a cancer, but he was predicted as he was not having a cancer, so this is a disaster. At that time, we should specifically use recall. Now, in short, guys, whenever your false positive is much more important, go and blindly use precision. Whenever, with respect to your problem statement, if your false negative is important, at that time, you go and use recall. I gave you an example, guys. Okay, cancer, whether a person is having cancer or not. Some more examples, whether tomorrow the stock market is going to crash or not. Some example of precision, spam detection, right? Consider this particular example, try to think. Always our aim should be to reduce false positive and false negative, but whether false positive is playing a greater impact or role in that specific model. If it is playing, go and use precision, focus on precision. If false negative is actually playing a greater role or a greater impact it is having, just go and use recall. Now I want to introduce you to something called as F beta. Now sometimes in some of the problem statements, guys, false positive and false negative both are very, very important. Okay, in an imbalanced data set I'm saying. Okay, both will be important. At that time we have to consider both recall and precision. And if you want to consider both recall and precision, we basically use F beta score. Okay, F beta score. And sometimes in some of the problem statements, guys, even though recall play a major role, that is like false negative play a major role or a false positive play a major role, you know, some of the problem statement you should try to combine both precision and recall to get the most accurate value. So for that particular case, we use a F beta score. Now here I'm going to define a F beta score formula for you so that you will be able to understand. So now let us go and understand what exactly is the F beta score, guys. In F beta, usually the main aim is to select this beta value. Okay. Now how we should go ahead and select the beta value, I'll just tell you in a minute. But just understand one thing, guys. This exactly, if I just consider my beta value is 1. Okay. This basically becomes an F1 score. Okay, this basically becomes an F1 score. How to select, when to select beta is equal to 1, I'm just going to tell you in a while. Similarly, beta values can vary. It can also be less than 0.1, it can be 0.5, it can be 2, You know, if it is 0.5, we basically say this as F 0.5 score. If it is 2, we basically say that F 2 score. Okay. Now, I hope I don't know whether you have seen this particular formula, guys, but just understand this is my F beta, and initially we need to select this particular beta value. Now consider that if my beta value is 1, now this formula basically becomes 2 into precision multiplied by recall divided by precision plus recall. Okay, and this is basically called as a if you don't know about this, guys, this is called as a harmonic mean. Harmonic mean. If I replace this precision recall by x and y, so this will become 2xy divided by x plus y. I hope you have been familiar with this particular formula itself. This was we used in some of the linear algebra in your school days and in your college days, if you remember. 2xy divided by x plus y. I'm considering precision and x, recall as y, precision over here as x plus y. Okay. Now, understand over here, when should we select beta is equal to 1? Now, understand, guys, if you have a problem statement where wherever true positive, sorry, not true positive, false positive and false negative, both are equally important. Both are having a greater impact. At that time, you go and select beta is equal to 1. Okay. Now, in some of the scenarios, suppose your false positive is having more impact than the false negative, that is then the type 2 error. Okay, false positive is the type 1 error. At that time, you reduce your beta value to 0.5, between 0 to 1. Usually people select it as 0.5. At that time, this beta value will get converted to 0.5. So it will be 1 plus 0.25. This is nothing but 1.25 multiplied by precision into recall divided by, this will basically become 0.25 into precision plus recall. So whenever your false positive is more important, we reduce this beta value. Now similarly, if my false negative is high, false negative impact is high, right? That is for recall, if you remember, guys. Okay, if that is high, at that time we specifically increase my beta value greater than 1. Suppose I consider it as 2. Right? At that time, what will happen? Again, I'll try to apply in this beta value, this particular 2 value. This will nothing be but 5 multiplied by precision into recall divided by 4 multiplied by precision plus recall. So, if false negative and false positive are both important, we consider beta is equal to 1. If false positive is more important, at that time what we do? We reduce the beta value. If false negative is having a higher impact, we increase the beta value. And that is how we select this F beta value, and sometimes we say it as F1 score, sometimes we say it as F2 score, sometimes we say it as F 0.5 score. Okay, considering this particular values. And again, guys, based on this false negative also, sometimes your beta value ranges between 1 to 10. Okay, considering where your false negative is having a greater impact. When your false positive is having a greater impact, you basically select a value somewhere between 0 to 1. And that is why we specifically use F beta, where you want to combine both precision and recall and try to showcase a particular problem statement and try to select the right kind of metrics. This each and every parameter is very, very important, guys. So I hope you understood this particular videos, guys. In the part 2, we'll be discussing about Cohen-Kappa, ROC curve, AUC score, PR curve, and there are two more metrics which I'm going to discuss in the next part 2. In the part 3, we will basically be implementing a practical problem statement to make you understand all these particular things. So I hope you like this particular video. I know this is too much. Just go revise it. You'll get to know each and everything. So yes, this was all about this particular video. I hope you like it. Please do subscribe to the channel if you have not already subscribed. I'll see you all in the next video. Have a great day ahead. Thank you one and all.